Okay, so this is the key to topic 6, part C, and on this worksheet, that's where you were talking about solving absolute value equations. And so let's take a look at that. So one of the things you got to remember though when solving absolute value equations is this. I'm going to go ahead and remind you. All right, so remember our the way we're going to set up the solution process. So if I have the absolute value of, let's say, A is equal to B. So and remember you're only looking at situations where, in this case, where B is a real number. Okay, and also keep in mind that if B is a real number and it's positive or zero, we're going to end up with some solutions here. So you're going to have this algebraic expression equal a real number. So whenever you have this, then the way we set it up is, and we talked about this in the lesson, we went into more detail in the lesson, but basically what's going to happen is you're going to say, all right, if I have an absolute value equation and the absolute value expression is by itself and it's equal to some number, some real number, then I can write this as A is equal to B, or A is equal to the opposite of B. So notice the opposite of B is the negative B. So notice that whatever's inside the absolute value bars, you see it here on both equations. And then for the right hand side, you wrote B again, and then you took the opposite. So remember, if you go back to the lesson, it measures the absolute value. When you think about it, is the distance that a number is from zero on the number line. That's how we defined it. So that's the idea we use here. So you have B and you have the opposite of B. Okay. Now keep in mind that this is true right here if B is greater than or equal to zero. All right. Now we also saw this, and I don't think we have this situation here, but we also saw this. If you have the absolute value of A equals a negative number, let's say negative 2, then we saw that's no solution. All right. So you wouldn't do this. You would not do this. You would just say no solution because the absolute value of an expression is always positive or zero. Okay, it's never negative, and positive or zero is never equal to negative. So this would never be true. Okay. All right, but we in each of those though, you're going to see that this number on the other side is going to be positive. Okay, so this is what we're going to use. We're going to write each of those absolute value equations into two equations without the absolute value bars. So number one, we have the absolute value of 2x minus 1 is equal to 6. Okay, so these are simple absolute value equations. So notice that the absolute value expression is already by itself. I have a positive real number on this side. So right away, I can rewrite this without absolute value bars. Whenever you rewrite it, that's where you get two equations. So remember, whenever you have an absolute value equation, you're going to rewrite it as two separate equations without absolute value bars. So this statement is true. This is a true statement as long as 2x minus 1 equals 6, or 2x minus 1 equals the opposite of 6. So remember, like we did here, B, negative B. If this is B, you'd say B, negative B. If this is 6, you say 6, negative 6. That should be negative 6 here. Okay? And then notice I went from an absolute value equation to two linear equations. So let's solve each of those linear equations. So I'm going to add 1 to both sides. So 2x equals 7. Divide by 2. I get x to be 7 halves. So there's one of your solutions. Over here, add 1 to both sides. Combine like terms. I get 2x equal, this is 0 here, negative 1 and 1, 0. But negative 6, remember that's a negative 6, plus 1 is a negative 5. Divide both sides by 2. I get x to be a negative 5 halves. And so there's your other equation, or your other solution. All right, so that was number 1. Okay, let's look at number 2. Number 2, I have the absolute value of 3x plus 4 minus 2 equals 3. Okay, now remember, you can only split it apart into two separate equations without absolute value bars as long as the absolute value expression is by itself. And in number 2, I don't have that yet. See, you gotta get this part by itself right here. this part. Okay? So that means I got to get rid of this negative 2 first. So I'm going to go ahead and add 2 to both sides. So I get the absolute value of 3x plus 4 is equal to 5. And now notice I have the absolute value expression equal to a real number that's positive. So therefore, I can go ahead now and rewrite it as 2 separate equations without the absolute value bars. So I get 3x plus 4 is equal to 5, or 3x plus 4 equals a negative 5. 5 and its opposite. 6 and its opposite. Okay? And then we're going to subtract 4 from both sides. So notice I have 2 linear equations now. Now I want you to, before I go on, notice that when I wrote it as 2 separate equations, you did not see any absolute value bars, so don't do that. It's got to look just like this. So you get the absolute value expression by itself, get the absolute value expression by itself. The next step is to rewrite it without absolute value bars. If I see any absolute value bars here at this point in any of these, you're not going to get full credit. You made a mathematical error. Okay? All right, so then combine like terms, I get 3x equal 5 and a negative 4 is 1. And then divide both sides by 3, I get x to be 1/3. So there's the other solution. And then, you know, if you want to check it, and I just want to check this one right here just to show you. Now, most students will on a quiz or a test will not, if it's timed, will not have time to check. But you can do it in this case, and for this one, you can do this mentally very quickly. Because watch, listen to me carefully. Always go back to the original. 3 times x, remember saying x is a third? What's 3 times a third? Well, remember I'm saying 3 times a third, right? 3 times a third. Well, 3 times a third is 1. What's 1 plus 4? Well, 1 plus 4 is 5. What's the absolute value of 5? Well, the absolute value of 5 is 5. What's 5 minus 2? 5 minus 2 is 3, and that's what you wanted. You see? All right. But in your mind, this is what you have. You have 3x plus 4 minus 2 equal 3. So in place of x, I'm going to substitute 1/3. And so I get the absolute value of 3 times a third plus 4 minus 2, and we see that's going to equal 3. Okay? Well, 3 times a third, remember, is 1. The 3's divide out. So 1 times 1 is 1. 1 plus 4 is the absolute value of 5, and the absolute value of 5 is 5. Well, 5 minus 2 is equal to 3. Okay? So 1/3 does work. All right, let's do the next one. So we're going to subtract 4 from both sides. Combine like terms. I get 3x equal negative 5 and a negative 4 is a negative 9. Divide both sides by 3. I get 3 divided by 3 is 1. 1 times x is x. So I get x to be a negative 3 because negative 9 divided by 3 is a negative 3. Okay? All right, number 3. Number 3, I have the absolute value of 5 minus 2x is equal to 4. So again, the absolute value expression is already by itself. This is a positive real number. So I'm going to go ahead and rewrite this as 2 separate equations without the absolute value bars. So I'm going to say 5 minus 2x equals a positive 4. 5 minus 2x equals a negative 4. 4, negative 4. And then you have these 2 linear equations. So let's go ahead and get the variable x by itself. So I'm going to go ahead and subtract 5 from both sides. Combine like terms. 5 minus 5 is 0. So I'm left with a negative 2x. Be careful with the sign. Some of you are going to make a mistake and say 2x, but that's a negative 2x. Equal 4 and a negative 5 is a negative 1. Divide both sides by negative 2. Just like this. Negative 2 divided by negative 2 is 1. 1 times x is x. A negative divided by negative is a positive, and so that's just 1/2. So there's your solution. One of them. There are 2 of them. Then over here, we subtract 5 again, combine like terms. So I get negative 2x is equal to a negative 4 and a negative 5 is a negative 9. Divide both sides by negative 2. Negative 2 divided by negative 2 is 1. 1 times x is x. A negative divided by negative is a positive, and so I get 9/2. And that's it. Now, if you want to write this one as a mixed number, you can. So you could have said x equal, was that 4 and 1/2? Okay. And then finally, number 4. Number 4, we have the absolute value of 2/3 x minus 1 is equal to 3. Okay, so this one has a fraction in it, and you have enough experience to deal with fractions. in an equation. Okay, so again, notice the absolute value expression is by itself, so we can go directly and rewrite it as two separate equations without the absolute value bars. So I get 2/3 x minus 1 equals 3. 2/3 x minus 1 equals a negative 3. So 3, negative 3. So remember, the best way to solve these two is to go ahead and add 1 to both sides first in both cases, just like this. Add 1 to each side. Combine like terms, this is 0, so I get 2/3 x equal 3 plus 1 is 4. Over here, I get 2/3 x equals negative 3 plus 1 is a negative 2. All right, at that point, what I would do next is see how I'm dividing by 3, and the opposite of dividing is to multiply. So I'm going to go ahead and clear the fraction, so I'm going to go ahead and multiply both sides by 3 since that's the least common denominator, just like this. Okay, both sides by 3. 3 into 3 is 1, 3 into 3 is 1. Remember, that's the whole point. That's the reason for multiplying by the LCD is to get this factor here to be a 1. So 1 times 2 times x is 2x equal 4 times 3 is 12. And then finally dividing by 2. 2 divided by 2 is 1. 1 times x is x. So one of my solutions is 6. 12 divided by 2 is 6. Over here, same thing. These divide out. Remember, the whole point of multiplying by the LCD is to get this to be a 1. 1 to get this denominator to be a factor 1. So 1 times 2 times x is 2x equal. Negative 2 times 3 is a negative 6. To get x by itself, right now I'm multiplying by 2. The opposite is to divide by 2. And so 2 divided by 2 is 1. 1 times x is x. So I get x to be a negative 3. And so those are your two solutions. And so that is the key to solving those absolute value equations. And those are simple absolute value equations because all you had on the other side was just constants, real numbers. So that was easy to deal with. Okay, so that's the end of the key to topic 6, part C, and this was worksheet number 1 for that topic.